The candy Skittles comes in 5 colors/flavors: green, orange, red, purple, and yellow. The company claims that each bag of Skittles has an equal number of each color. Use a 10% level of significance and the data below to test the company's claim. So clearly we're testing a hypothesis, right? By this phrase, test the company's claim, right? Test the company's claim, and then we have a 10% significance level. And we're basically saying that the proportion of these flavors are all equal to one another. So it's a hypothesis test about proportions, and there's more than 2 proportions. This means we're going to be using the chi-squared procedure we've learned. So let's talk about the claim for the problem starting out. The claim is pretty straightforward. The company's claim is that they're all equal, right? So it means the proportion for green is equal to the proportion for orange, is equal to the proportion for red, purple is equal to the proportion of yellow, right? So they're all equal to one another. That's how I'm going to express the claim. Now HO would be the same as the claim here, since the claim is involving all these equal signs, right? And that's basically what the claim is when, or that's basically what HO is, that all the proportions are equal. So the claim, of course, being that same thing is going to be the same as HO. All right, then we're going to look at HA now. HA is at least one proportion differs, right? Significantly. We just say at least one proportion differs. And then dot, 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 you know what we mean by that. Okay, now from there, after that, the next procedure, next part of the procedure is to come up with a chi-squared test statistic after manipulating all the data that we have to deal with, right? So we have a lot of work to get to the point where we can get the test stats. So let's play with the data a little bit. We have to write down all these numbers first, the observations. Okay, from there we have to write down the expectations. Expectations are going to come from multiplying the total of the observation column by the appropriate probability for each category. So let's start by totaling up the observation category, or the observation column, excuse me, to see what our total is, right? Because we're going to need our n, our sample size, essentially for the problem. How many Skittles did they look at here? So you have 43, 50, 44, 44, 52. And you do that, you get 233. All right, now what we're going to do is take that n and multiply by each of the corresponding probabilities for these cells. Now, if they're all supposed to be equal to one another, and we have a total number of categories of 1, 2, 3, 4, 5, then that would mean essentially that each must be 20% of the bag, right? 20, 40, 60, 80, 100. Or you can say that each must be 1/5. So we have to multiply this total by 1/5 for every expectation in the table, right? So do 233 divided by 5, and you will have your answer for the expectations. If you get 1, you have them all because they're all supposed to be the same. So we'll say 46.6, 46.6, 46.6, 46.6. Okay, so that's the expectation column. Then from there we have to do observed minus expected. So do the subtraction all the way across for each of these. So let's do that quickly. We're going to do, I'll just do it here. So we're going to do 43 minus 46.6. We get the answer negative 3.6. Then we'll do 50 minus 46.6, 3.4. 44 minus 46.6, so 2.6 on the negative side, right? Then negative 2.6, and then lastly 52 minus 46.6, and get the answer 5.4. Okay, now next step is observe minus expected quantity squared. Square the results for each of these, right? So 3.6 squared is going to be 12.96. 3.4 squared is going to give you 11.56. Then 2.6 squared is going to give you 6.76 and 6.76. And then 5.4 squared, and you get the answer 29.16. Okay, so that's your observed minus expected squared. And then our last column, the last one we have to do is observed minus expected squared divided by expected. And when you're finished with this, you will have enough information to get your chi-squared test stat, because all you have to do is sum that up to get the total at the bottom. All right, so let's work that out then. Let's do observed minus expected. So that's going to be 12.96 divided by 46.6. And actually each of these is going to be divided by 46.6, right? So we're going to have 0.2781 to 4 decimal places. And what I'm going to do to actually make things move a little faster is I'm going to store the 46.6 in my calculator as x. So it'll just be a little bit less keystrokes as I do it. So 11.56 divided by x. And that's going to give you 0.2481. Then I'll have 6.76 divided by x. And we get the answer 0.1451. So 1451. And then it'll be the same for the one below it because it's the same number. And then 29.16 divided by x. And we get the answer 0.6258. Okay, let's add that column up and get our result. As a result, we'll have 0.2781 plus 0.2481 plus 0.1451 plus 0.1451 plus 0.6258. Okay, and so if we didn't make any mistake, we have the answer 1.4422, which is a pretty small chi-squared value, right? It's a pretty small chi-squared number. And that's good. That indicates there's a lot of similarities between the observations and what we expected to see, right? Okay, so maybe the company here has the right proportions. They say they're all equal and maybe they're telling the truth. All right, let's take that number then. We know this is our chi-squared test stat, and let's compare it against a critical value. But in order to do that, we have to calculate the critical value, determine what it is. So let's go do that next. Okay, so let's get our critical value now. We'll have a curve that draws like this, heavily right skewed just to get a visual aid going. And we'll have a rejection region on the right-hand side here. We're looking for the critical value here that will separate the rejection region from the do not rejection region on this number line. Now, as far as the symbol, of course, it's chi-squared, and we're going to have the alpha, which is 10% here, so 0.10, and then we need the k-1 degrees of freedom. So the number of categories we have is 1, 2, 3, 4, 5, so 5 minus 1 is 4. This is the notation for our chi-squared critical value. Let's go to our table now, look up in the 10% column, 4 degrees of freedom, and we'll find our corresponding critical value. Okay, so we're on the chi-squared table looking up 0.10. That's our area in the tail. With 4 degrees of freedom, we get 7.77944. Okay, so our value turns out to be 7.779, right? And let's compare that against our chi-squared test statistic that we calculated earlier. So in our work earlier, we found that our answer was 1.4422. That was our chi-squared test stat for this problem. Now, basically that means that our chi-squared test stat is going to be in the do not reject region, right? Because this value clearly lands in here somewhere, right, in the white space. So we'll say do not reject HO, and therefore do not support HA. Do not support HA. Now, if you look back at our original work here, you can see that our claim in the problem was the same as HO. So we're saying do not reject HO. So do not reject the company's claim. So we're going to say the sample data does not allow us to reject the company's claim. The sample data does not allow us to reject the company's claim. That essentially all the colors come in equal proportions.